What's up, you data friends? It's Yanis here and welcome to my channel. In this video, we are going to try and predict the football players' market value based on their statistics. And more specifically, we are going to try and follow this structure down here. First, we're going to start by loading the player statistics, which is some Excel raw data that I got from Kaggle. So this is the raw data, as you can see over here, and the columns we have, the statistics, is basically all of these fields you see over here. So this is a lot of statistics per football player. Then we are going to get a list with all the football players that we have statistics for, and we are going to use web scraping in order to get their current market value from this website over here, the Transfermarkt. So the code is going to get the player's name, it's going to paste it here, it's going to click search. Let's get an example so you can understand very quickly. So let's use this first person over here. So the code is going to do this, it's going to click enter, and it's going to get this number over here as the current market value. Then I'm going to go back over here to our structure. We are going to go through all the data pre-processing stages you see over here: data cleaning, missing values, aggregations, and visualizations. Then we are going to model our data. So we are going to do correlations, run machine learning, hyperparameter tuning, and then we're going to store our models and results. And then we are going to deploy our model into this Streamlit app you see over here, where you get to change, all of these variables that the model needs in order to predict. So let's say year 22, click enter, and then predict the market value. And this is going to give us a market value for a player that has these statistics you see over here. Right, going back, and before we jump into this video, let me just say that if you're passionate about data analytics and data science, then please consider liking this video, subscribing to my channel, and enable notifications for my future videos. Right, coming down here now and starting with the process we are going to follow for our machine learning problem. First, we're going to try and formulate our problem, so write down all the questions we're trying to answer. Then we're going to gather our raw data. We're going to go through data pre-processing. We are going to split our raw data. We are going to select and train an initial machine learning model. We are going to evaluate it. We are going to do some parameter tuning. We're going to repeat this process until we are happy with the final model. We are going to store our model, and then we are going to deploy our model in this Streamlit app we have over here. Right, going back, the problem we are trying to solve is that we want to understand which variables increase the market value per player. We want to be able to make predictions on the market value per player. And we also want to identify over or underperforming players based on their market value. So basically, if we have valued them too much or if they are undervalued. Right, starting with loading our raw data, we have this Excel file over here called player statistics. And you can actually download this file from the link below, which is this one over here, from Kaggle. And what I'm doing here is that I am just displaying the first 5 rows. So this is all the raw data we have and we are going to use for our model. As you can see, we don't currently have the market value, which is our target variable. And this is where we need to run the next step, which is basically pulling the market value from the Transfermarkt website, which is this website over here that I have just shown you before. Let me copy paste. Yeah, this is the website. So in order to do this, we're going to need to first create a list with all the unique player names. Then we have to set the base URL that we're going to add the player name at the end of this URL and get the market value. Then we are going to store the length of this list into the total players, so we can actually see live at which player we are, 1, 2, 3, 4, etc., etc. Then we are going to have this for loop over here, which says for I and player in the player list, which is this list we have over here for all the players, is going to first construct the search URL is going to print processing player, the number of the player, and then the player itself. So like this, as you can see, the number, the total, and then the player itself. Then it's going to try and fetch the data. So it's going to send a request with the URL we have just constructed over here. It's going to raise a response. It's going to store the HTML into this soup over here. And then it's going to try and soup.find this class over here, which is basically where we have the value of the player. Then if it does find that value tag, it's going to strip the value, so everything from left and right. Otherwise, it's going to throw this error. And down here, it's going to store the results into this results list over here that has the player name and the market value. Otherwise, it's going to throw an error. And this is doing time.sleep 2 seconds, so we avoid being blocked from the website. Then we are storing the results in the data frame, and then we are printing the data frame, and then we are also saving the results in a CSV file. And this is because when I have initially run this, it took 1.5 hours to run. This is why I have stored the results. So I suggest you should do the same when you run this piece of code. So just to show you an example quickly, I'm going to comment this out so I don't store the data on top of the actual data. I'm going to do player list equals, and then we're going to pass one player. So I'll show you how it works. So over here, I'm going to select this player like this. Maybe let's do this player. I think it's easier. Like this, comment this out, click run. There you go, we have one player and you can see the value. And then if I show you how it works, the search URL, if we print this, let me do this quickly, like this, you can see it constructed the URL with this player name. If I click on it, you're going to see the page. Then we need to load the HTML file, which is basically this soup over here. So if I run this, you can see this is the HTML file. And if we find this class over here, the rechtshaupt link, whatever it's called, then this is going to find the actual market value from here, and it's going to store the market value in the data frame. So that's how this is going to work. However, I'm going to remove this, I'm going to uncomment this, and I'm also going to remove this over here and leave the whole player list. I'm not going to rerun it because, as I said, it takes 1.5 hours, but you can run this yourself and store the results into this CSV file over here. And then if we check the results, actually this is only going to have one player now because I have rerun it. However, over here I'm just loading, so reading the existing results, and this is going to have all the data in. So if I do this quickly and then head like this, this is going to have all the players and the market value. So what I'm doing next, after I'm loading the file, is that I'm removing the data that we could not pull market value. So anything that has not found or anything that has a dash, I'm going to remove it, so not equals, from our main dataset. Then this function is going to convert the M's into millions and the K's into thousands, just because the way they have the values, as you can see, is 11M, so 11 million. However, I cannot use this as a value. I cannot aggregate this. I need it to be 11 million in a full number. So this is what this function does. And over here, I'm just applying my new function into my market value. Then I am just joining the market value into our main data frame, which is the one with the statistics. And down here, I am just filtering out all the players that do not have a market value from the statistics data frame. Before we did it for the market value data frame, now we are doing it from the statistics. And if I run this quickly, you can see that we have our initial data frame, but at the end, we also have the market value, which is not clean, but we also have the clean market value in euros. And this is actually a number now, it's not text. Right, moving on, we're gonna start our data pre-processing phase. And the first thing I always do is that I investigate all the elements within each feature. And to do this, I'm saying for column in the player row, which is our main data frame, which is this one over here, First, I store all the unique elements within the column into the unique values. Then I count the length of those unique values. Then if the length is less or equals to 12 elements, I actually want to print all of those elements. Otherwise, I just want to see the total length. So as you can see, the first column, which is RK, which I think is just an index. So let me check. RK, yeah, it's just an index. It doesn't mean anything. We have 2,496 distinct indexes. And then in the unique players, you can see we have 2,343. So straight away, this is telling me that I have players, distinct players that have more than one row. So duplication, so that's something we have to address later on. Next, all I can see is that I only have two categorical features, which is the post position, so whether it's a defender or a goalkeeper or a midfielder, and also the comp, which is basically the competition. We can see we have 1, 2, 3, 4, 5 different competitions. Everything else is numeric fields that take X distinct values. Right, the next thing I do is that I investigate if we have any null values. So if we run this, we can see that we only have one null value in this, nation over here. So what I'm doing is that I'm setting that null value into other. This is all I'm doing over here. Next, I want to check the players that are duplicates. So this is something we have identified from the step before. So if you run this code, it's going to return all the rows that have duplicate player names. So as you can see, this first player, it has the same values, but in squad, it played for different squads. The next player, it has the same values, but it played for both different positions and different squads and different competitions. Sorry, I haven't checked this. So what this is telling me is that everything from player and next can have different values. So what I'm going to do now is that I am going to aggregate my data so I don't have duplicate player names, and I'm going to only take the first option. So the first nation, the first position, and the first squad, and the first competition, and then I'm going to average the rest. Sorry, for some of them I'm going to sum, and for some of them I'm going to average. So things like, let me check, the first age, things like the minutes, which is the total minutes played, I'm going to sum. The goals, I'm going to sum. But the percentages, I'm going to average. So this SOT percentage, if we check what this is, SOT percentage is actually the shots on target percentage. I do not want to sum this because it's a percentage. I want to average this. So I repeated the same process. So this is a massive aggregation. For categorical variables, I took the first. For variables that I had to sum, I've summed them. And then for variables that I had to average them, I've used min. And for our y variable, which is a target variable, I have actually used the average for these duplicate players. Now, if I run this and check for duplication again, you can see that now I don't have any duplication. Right, moving on, the next thing I do is that I need to visualize my data. However, because we have a lot of different features, I want to break this down into maybe 5 or 6 features at a time. So down here, you can see I'm using pair plots to investigate the relationship between the features and my target variable, which is actually the market value in euros. So let me undo. So I'm starting with the first 5 or 6 features. And as you can see, I don't really see much of a relationship. Maybe the age has a negative relationship. Maybe the minutes played has a positive one, but it's not super clear. Then I move on to the next 6 variables. Maybe some relationships here. The next variable, maybe some negative relationships over here. Down here, nothing too good. Keep investigating. So what I'm doing is that I am keeping all the code the same and I'm just changing the variables. No relationship, maybe here, yeah, I keep going, nothing. Yeah, this does not look promising, so I don't see many positive or good relationships. So this is the first flag that our model maybe is not going to be that good. But we don't know yet. We need to investigate it, run it, and check. Right, the next thing I'm doing down here is that I am visualizing my categorical variables, and I only have nation, position, squad, and competition. So what I'm doing is that I am just creating bar plots per categorical variable, and I'm summing the market value. So let's see over here, we do have this one, it's a big one, but we can't really see the nation. We're gonna have to actually see the data frame, but nation does not really bother me because it's basically from where the player is. So I don't really think it matters where the player is and how much money they should get. Next, position. As you can see, some positions get more money than other positions. Squad, again, some squads obviously gonna have a lot more money than other squads. Then the competition, Premier League is significantly higher in terms of total market value in euros. Yeah, okay, that's good to know. The next step I'm doing, I think I'm investigating the distributions now. So instead of actually pasting all my numeric variables over here, what I'm doing is that I'm selecting the data types where I include the numeric. So whenever I have a column that has this data type, it's actually going to store it into my numeric variables. And this is going to loop through all of my numeric variables. It's going to plot a distribution plot, and is also going to calculate the average for that category, and it's going to plot the mean on top of our distribution plot. So as you can see, if I expand this, this is the mean, the average age, it looks good. So now we have a lot of distributions actually to view. So the one I'm very interested is only the market value, our Y variable, which is this one over here. So this is showing me that I don't really have a normal distribution in terms of market value in euros. As you can see, we have these players over here that are massive outliers. And if I want to investigate them, so if I do this, and then I run this over here, copy, paste, and let's do more than 100 million, you can see that these players, if we check their market value, they have massive market values that are outliers compared to everyone else. But if you read these names, they're actually the big stars of Europe. That's why they're massive outliers. So what I can do is that I could actually remove them, which is what I did over here as outliers. But the reason I did this is because I have already run the model. I got bad-ish results, and I've tried by removing the outliers and see if I can improve the model. So it's up to you if you want to leave it. Actually, let's leave them in for now, and let's rerun the model at the end, see if we can get better results by removing these outliers. The next thing we can do is that we can also create box plots that they are telling us the outliers straight away themselves. So I'm doing exactly the same thing as I did before. I'm looping through every numeric variable, and I'm creating this box plot. And this is also going to tell me the same thing, that I do have a few outliers that I could address if I want to. As you can see, especially market value, it has a lot of outliers. However, we're going to leave them in for now and then come back and remove them and see if we can improve our results. The next step now is that I have to prepare my final data frame before I feed it into my models. So first I start by dropping the player and the market value from my data frame. So if we view our data frame quickly, which is this one, dot head, let me check. You can see this is our data frame. I am going to drop the player name because we cannot really fit this into an algorithm. It's a text. I'm going to remove the market value, and this is because we already have market value in euros, and this is the field we are going to need. And then for the next step, I am just turning nation, position, squad, and com into numeric representation, which is basically zeros and ones for these fields, so I can use them into an algorithm. So if I run this quickly, and let's check our categorical variables, you can see created all of these categorical variables, true or false, 0 and 1, for all of our categories. So now our data frame is ready to be modeled. The first modeling technique I'm going to use now is the correlations, and more specifically, it's going to be Pearson correlations with a heat map. However, because I couldn't fit all of our variables in one heat map and visualize it in a good way, I had to split them up into 25 at a time. So what I did is that I have selected the first 0 to 25 features. I've copied this, pasted it over here, run correlation, and then run the SNS.heatmap, plot it over here. And then the one I'm very interested is this line down here at the end, which is the market value in euros. So as you can see, we don't have any variable that is strongly correlated with market value euros, which is not actually good news. Next, I check the next 25 variables, which is these ones over here. And then again, I check market value euros. Yeah, not much of strong correlations here. Then the next 25, and then the next 25. And then the last variables down here, which I don't know the number, is from 100 and after. And if you check all of our visuals, none of them is giving us a strong correlation for market value euros, which basically means on a one-to-one relationship, there is not a good predictor of market value. However, we don't know, maybe in the machine learning phase, we're going to get some good results. Right, the next technique we run is feature importances. So I identify and also order the features that contribute to the market value the most. To do this, we're going to have to run a tree-based estimator. So a machine learning, but it has to be a tree-based one. So what I'm doing here is that I'm splitting my data into X and Y. X is all my variables excluding market value in euros, and Y is just market value in euros. Over here, I run my decision tree, and over here, I print the score just to see if it does any well. As you can see, this one has 60% accuracy, which is not good, not bad either, is average, I would say. And then down here, I am basically calculating all the feature importances per variable. I'm storing it into this data frame over here. And down here, I'm just sorting my data frame from highest to lowest. So as you can see, the feature that contributes to market value the most is actually age, then min, which is the total minutes played, then if the competition is Premier League, etc., etc. So if I scroll into this, oh, it's actually the top 5. So if I check all of them quickly, just to see which ones are not contributing. So if we come, yeah, basically from down here and under, all these features, they don't contribute nothing into market value in euros. Yeah, just something to keep in mind. So let's do this again. Sorry, I cannot run it again, so I have to rerun this and then rerun this. It throws me the error, and it's because it already exists. So I'm going to have to rerun the whole thing. I'm going to pause the video, come back and run it. Or actually, I can just drop this data frame and then rerun it. So it's actually quicker. So I can do delete, run, fine, drop, rerun. There we go, fine. Next, we are going to run our XGBoost model. So first, we are going to split our raw data using holdout method, so holdout validation. So we're going to use 20% to test our data and 80% to train our model. We are going to initialize our XGBoost. We are going to use squared error as our objective, which is basically our metric. I'm going to change this later on. I'm going to show you. Then we are going to train our model, we are going to make predictions, we are going to evaluate our model, both the training and the test. So if we run this quickly, you can see we get a massive mean square error, which means our model is way off. We get 81% R squared, which looks good, but is not good. And we get a 38% R squared on our test dataset, which is basically unseen dataset. So this is telling us our model is actually terrible, I would say. It's not good for prediction, it's actually worse than random. What we can do is that we can go back and remove the outliers and try again. I think that is going to improve our model a bit. So if we go, where is it? Where are the outliers? I think it's, there we go, I think it's over here. If we remove them from player_AGG, and then we're gonna have to rerun this one, there we go. And then we run our model again, which is, where is it? Down here. Yeah, first we need to run the X and Y first again. Yep, like this. And then what else? Run the feature importances again. And then we also, oh, this created duplication. Sorry, again, I have to drop it. So delete. Yeah, you have to be careful when you're rerunning stuff so you don't do any mistakes. Click run, fine, and then rerunning our model. Yeah, you can see we got our R² on the test dataset to be a bit higher. However, it's still worse than random with a massive mean square error. So what we're going to do now is that we are going to attempt to tune our hyperparameters and see if we can improve our results. So over here, I have a few different parameters that I want to loop through and test. So this is going to create different combinations of these parameters. It's going to initialize my XGBoost regressor, and it's going to use a randomized search CV in order to go through all these possible options. It's going to feed it first. It's going to extract the best parameters and train the model again. So after it finishes, it's going to select the best parameters. It's going to extract them, run my final model. It's going to make predictions using my final model. It's going to calculate the metrics over here that we need to evaluate our model. And it's also going to create this data frame over here, which is the final feature importances. So if I run this again, make a note that this might take a lot of time to run because over here we are attempting 100 different feeds in order to find the best one. There we go, it finished running. As you can see, we get the best parameters over here. We have managed to massively improve the R² on the training dataset, which means we're probably overfitting. However, on our testing dataset, it's still terrible. It's an improvement from previous model, which is basically, how much was it? 47%. However, it's still very low and extremely random when it comes to making predictions. So the next thing we're going to try now is that we are going to try and filter all the features that do not contribute nothing to our model and try and rerun our best model and see if we can improve the results, which is basically copy paste of the code above. All I have changed is that I have limited my features into only features that have more than 0. So they actually contribute something to our model. So if I check again now, I don't need the features. Yeah, no, I still did not manage to improve our R² at all. So now what we can do to improve our model is that maybe we can try different models. Maybe we can try different learning methods over here, or maybe we need to run models by different categories. I think this is going to be the best one. So if we run one model per league, so Premier League alone, for example, or if we run models per position, because as we have seen from our analysis, different positions have different market values. So some positions pay more than others. So that could help us make better predictions, have multiple different models depending on the league or the position. However, for the purposes of this video, I'm going to stick with this model and show you how we can deploy it using a Streamlit app, because it's going to take us way too long if we keep trying to improve our model. But please keep in mind that this is a terrible model and you shouldn't actually use this to take any decisions, or you shouldn't really deploy any model that does not have good performance metrics. You should just go back to the business and say, I've tried X, Y, and Z, and the model is not actually performing. Trust me, this happens a lot more. So as a data scientist, you're going to develop a lot more models that you could not actually take into productions because they are not really performing well. So it's not always that you can make a model perform well. However, we're going to keep going on for the purposes of this video, as this is just educational. Right, what I'm doing here is that I am just plotting the Y test, which is the actuals, versus the Y predictions, which is our predictions. So you can actually visualize how far off is the actuals from our prediction line. You can see these ones over here, they're way out. These ones and these ones, they're way out. But some of them are actually spot on. So these ones over here. Right, next step now is that we are just saving our model using pickle. So what this does is that it takes our best model, the XGB underscore model under selected, and is using pickle.dump to save this model into this file over here. And if I check, this is the model over here, XGB underscore final underscore model into a pickle file. The reason we are doing this is so we can actually call this model from our Streamlit app, which is this one over here. I'm going to show you later on. Next, I'm also storing the feature importances, and the reason I'm doing this is so that I can then load it into my Streamlit app and create this Plotly bar graph over here. This is why we are storing it. And we are also adding the total predictions into our main data set. So these all DF predictions is actually, let me find it quickly to show you. There we go, is this one over here. It's basically on our previous model, but that's fine. It's basically predicting from our best model on all of the data set. So all the rows, not just the test or the train, it's all of them. So I can then take it back into my main data set and I can then create a dashboard or create visualizations. So this is what I'm doing here. And then I'm exporting the final DF as player underscore data with predictions in an Excel file. Right, the next step now is to create our Streamlit app, which is this code over here that creates our app over here. However, I'm going to do this in the next video just because this video already took too long. Right, so I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos.